Welcome back. Getting back into the swing of things with video notes. I know you missed it, so we're gonna get into it. Okay, so this is a reminder. Video notes, when we watch them, we also take notes, so you need to be taking notes right now. 5.1, factoring integers. Okay, so we're starting to get into factoring this chapter, so we're going to start small and kind of work our way up to factoring. Okay, so factoring integers. Well, let's go over some definitions. What's factoring? Factoring, giving all the numbers that divide evenly into a given number. Usually we factor within positive integer sets. Okay, so this kind of might sound a little confusing, but basically when we say evenly, we need it to be integers. Okay, so you can't be like, you know, 5 divided by 2 is 2.5. Yes, that is correct. But when we're factoring, we typically use positive integer sets. Okay, so positive numbers and integers, which we remember that integers were some stuff. Again, there's an infinite amount of integers, but it could be integers are -3, -2, -1, 0, 1, 2, 3, and so on. But we did say positive, so we would be canceling out all of these, and we would start with the 1, 2, 3. Okay, so that's just a kind of a reminder. So if I were to giving all the numbers that divide evenly, so for example, if I was trying to find the factors of, again, another word, factors, another form of that, factors of 18. Well, we think about that and we know that, okay, well, 1 times 18 works. Now, it's kind of weird the way I'm doing it. I kind of like to work my way outside and have them match up with their factor and work their way in. If you want, you can write it however you please. Okay, so I have 1 and 18. Then I'm going to think the next number, 2. Is 2, can I divide 18 can 2 go into 18 evenly? Yes, because 2 times 9 is 18. So I'm going to put 2 and 9 as those factors. And then 3. 3 divided by 18, 18 divided by 3, again, got to make sure I say that order right, is 6. So I can write 3 and 6. Now I think about that, the next one, 4 does not go into it, and 5 does not go into it, and then I get, stuck there. 6 is the next one. So that's kind of shows me those are all my factors of 18. There's different ways to set it up. Again, how it looks, this is just my way. Do whatever way works best for you. So those are my factors of 18. Now, prime number. A prime number is a number whose only factors are 1 in itself. So, for example, we have 1. 1 kind of is kind of a special case because 1 and 1 is itself. It's kind of complicated. But then we can start with 2. 2 is so examples of prime numbers. So 2 is an example. Because that's 1 and 2. 3. 5, 7, not 9, can't think of only odd because 9 is 3 times 3. So you kind of go on from there. There's an infinite amount of prime numbers. Again, it has no other factors besides 1 in itself. Okay, prime factorization. This is when a given number is expressed as a product of only prime numbers. Product, what do we remember product is? The answer to a multiplication problem, I'm just going to abbreviate problem, okay? Got to keep that in mind. That's what it is. So it's so we basically can only have prime numbers and multiply them together to equal that number. So that's the prime factorization of that number. So let me too soon. Okay, so I'm going to say, what is the prime factorization of 18? Now we're gonna make this little tree, okay? And the way I do it is kind of like I think of prime factorization. I think of this tree. This is a really great way. Now you have to think of 2 numbers that are factors of 18. Do not pick 1 and 18 because then you're gonna be in a never-ending cycle. You have to pick something other than other than 1. So I can do 2 and 9, I can do 3 and 6. It doesn't matter because you're always going to get the same answer. So I'm going to do 2 and 9, okay? And I look at this 2 now. This 2 right here, that's a prime number, so I can't split it up because I don't want to split up 1 and 2, okay? Not using that. So then 9. I'm going to do 9. 9 splits up into 3 and 3. So look here, I have 2, 3, and 3 at the end of my prime factorization tree. So that means that the prime factorization of 18 is 2 times 3 squared, because we have 2 3's, okay? So we're going to write it with an exponent. So if we think about that, 3 times 3 is 9, times 2 is 18, and those are all prime numbers, so that is my prime factorization for 18. Now some people might think, hey, what if I used 3 and 6? Let's look over here. 3 is already a prime number, so I'm going to do that as 2 and 3. And again, order does not matter because of what property? The commutative property. So we have 2 times 3 squared. So same thing either way, okay? Just don't use 1. Oh, okay. So let me kind of erase that. Okay. So a common factor is a factor that is the same for 2 or more numbers. Okay, so that means like if you have 2 numbers and like they both can be divided by 2, that's a common factor. The GCF, or that is the greatest common factor, you need to know what GCF is. We're not always going to write greatest common factor. So if you see GCF, you have to know what that means. Is the biggest common factor between 2 or more numbers. So you're going to have to find their prime factorization. And then that's going to help you be able to find the largest number, and you'll see why in our example in just a moment. So here's our example. Find the GCF, which we know is greatest common factor, of 882 and 945. Now that seems like crazy big numbers, and yeah, if you want to use a calculator, I'm totally okay with that. It might be some guessing and checking because you might try to divide it by something that it doesn't work. If you try to divide 882 divided by 3, that might not work. It might work. You just kind of go from there, okay? So I'm just going to start, and I'm going to go with an easy one. I know 2 is divisible to 2 because it's an even number. So I'm going to say 2 and 441. Okay? So now I'm going to keep going. Okay, so I'm going to use my calculator and kind of use some numbers to guess. And, 3 works. So I'm going to say 3, and I know that it's going to be 147. Then I look at 147. I got to do some numbers, okay? So guessing and checking. So, you know, try 2. Does that work? No. Try 3. Does that work? So I am using 7, okay? So you might have different numbers if you guess and check. You should get the same answer. And then 3 and 7 here. Okay, so I end up having the ends of my tree are right here. So that is going to be my prime factorization for 882. So for 882, that, in order to get that to equal, that equals 2 times 3, and there's 2 3's, so that's 3 squared, times 7 squared, because there's 2 7's. So if you were to type that in your calculator, because we know that's 9, and that's 49, times 2, that's going to give you 882. So I found my prime factorization just for 882. But now I need to also find that for 945. So I'm going to divide. I'm using 5 and 189. Again, use your calculator. It's going to be your best friend. And then that splits up to 3 and 63. And that one's an easy one. So that's 7 and 9, and 9, 3, and 3. So now I have 5, 3, 7, 3, and 3. So I could write 945. Its prime factorization is, it doesn't have any 2's, but it has 3 3's, so it's 3 cubed times just 1 7, and I want to do it in order. 1 5 and 1 7. Again, it doesn't matter what order because of the commutative property, but I did an order from least to greatest number. Okay. Now, in order to find the greatest common factor, okay, I'm going to take these prime factorizations and see what they have in common. Do they both have a 2? No, I can't use that. This one has a 2, but this one doesn't. Now, they both have 3's. Well, this one has 2 3's, and this one has 3 3's. So I need to go with the 2 3's because they both don't have 3 3's in common. So really, they have 3 squared in common, okay? Because you could split this up. They don't have any, both have 5s, but they both have at least one 7. So that's what I'm going to put down there. And that will help me get my greatest common factor. So 3 squared is 9, and 9 times 7 is 63. So they are both divisible by 63. That's a factor of both of them, but that's actually the greatest one, and this is our way to guarantee that that's the greatest one. Okay? Give all positive and negative factors of 19. So normally we don't put negative factors, but it specifically asks for negative. So let's just first do the positive ones. So 19. So I have 1 and 19. 2 is not divisible. 3, 4, 5. Hopefully you quickly realize that actually it's only 1 and 19. So I'm actually going to write it a little closer. Ooh, why is my eraser not working? Okay, my eraser's not working, but it's 1 and 19. So what does that make it? Makes it a prime number. Okay, prime number. Okay, but it also asks for the negative, so I can do a -1 and a -19 because a -1 times the -19 equals a positive 19. Okay. Okay, number 3, give all factors of 64. Now it's asking for all factors, but we assume it's only positive. So we're going to say 1, 64. Then, is it divisible by 2? Yep, it's divisible by 2. And 2 and 32. Again, use your calculator if you need to. 3. Nope, 3 doesn't work. You can double check. And then 4. Yep, 4 works. 4 and 16. Does 5 work? Nope. 6, nope. 7, and you're going to keep going and you're going to realize it doesn't work. So these are the only ones. So that's all my factors of 64. And prime factorization of 84. Okay, so we've been working on this, another problem. So we're going to split that tree up. So we have, let's do 2 and 42. That's pretty easy. And then 42, we know that that could be 2 and 21. And then that will be 7 and 3. So my prime factorization would be 2 squared, because I have 2 2's, times 3 times 7. So that's my prime factorization. And last one, this one's a little bit easier, with not as big in numbers with the 800 and all that stuff. So we need to find the prime factorization of both of these first in order to find the greatest common factor. So 36. 6 and 6. Then that's 2 and 3, 2 and 3. So I know that 36 is the same as 2 squared times 3 squared, right? If I were to multiply that, that equals 36. Okay, if I do 90, we'll do let's do 9 and 10, 3 and 3, 2 and 5. Oh, now we can write 90 as 2 times 3 squared, because we have 2 3's, times 5. Now, how do we find the greatest common factor? Okay, we have to see what they have in common. Do they both have 2's? Yes, but this one only has 1, and this one has at least 1, so that's the only thing we can have in common so far. Now, 3's. Oh, they both have 2 3's, so I can use both of those 3's. And that's, this one, 36 doesn't have anything else, so I can't use anything else. So what is 3 squared? That's 9. And times 2, that equals 18. So that means our answer, our GCF, is 18. And you can double check that. 36 divided by 18, that works. And 90 divided by 18, that works as well. Okay? So, hope you enjoyed our first video notes back.